Good evening, students. This is Miss Wilson coming to you from a pre-recorded session over the weekend, working on system solving. Now, I know that I give you some little worksheets that the problems are not that hard. I want to show you some math counts problems that kind of make you think. Well, not all of them, but I still have some things I want to teach you. If you didn't get the notes before on solutions and inconsistent and consistent systems, I took this little snippet off purplemath.com. I'll cite them if I'm going to quote them so that I'm not stealing from them. Purplemath.com is a really good website, and so freeze this frame and write it if you need that. Let's go straight into problem solving. Now here's the deal, and I'm serious. Please let me make you a good student, a good math student. You have to freeze this frame and try to work this problem before I work it. Do it all by yourself, or you might as well just watch someone play the piano if you want to learn to play the piano. That doesn't work now, does it? No, it doesn't work. You have to try it first, and then when you see me solve it, your brain will have something to hook that to, even if you get it wrong. So freeze this and try it. Good for you if you did freeze it. Shame on you if you did not. Here's how I would solve this. I would say A is equal to the number of adults. This is called defining my variables. And C is equal to the number of students or children. Now, I know that on this given day, the number of adults plus the number of children came to 2,200. And at this fair on that day, the adults were charged $4 each. The children, 1.5 or $1.50 each. And the total proceeds for that day were $5,050. So I'm going to take this and multiply it by 4 in order to solve. And I know that children everywhere are screaming, no, -4. But I'll make my point. But look what happens. So if I multiply it by 4, 4a plus 4c is equal to 8,800. See, I want to make this negative because I don't want to be subtracting a whole number from a fraction that's lesser or a decimal. You'll see what I mean. If I'm going to work with decimals, I want it to be easier. I don't want a negative variable and a negative constant. In this way, I went around that. So 4a minus 4a is nothing. 4c minus 1.5, I can do that easily. It's 2.5c. And then 8,800 minus 5,050 is going to be 0, 5, 7, 3. And then I'm just going to, I am picking up a calculator, I confess, taking 3,750 divided by 2.5, and I get that C is equal to 1,500. So if there's 1,500 students or children, and I look at this, then there must be 700 adults. So I'm going to multiply 700 times 4, add 1,500 times 1.5. I do get the right answer, so this must be right, which means there's more than 2 children for every adult, and I think I'll stay home from the fair. All right, this is about bushes and trees. Oh, not that type of bush. That type of bush. Okay, so I want you to freeze the frame again. This one is pretty easy. And do this problem. Here we are. We're back, right? So we have 13 bushes plus 4 trees equals $487. And then 6 bushes plus 2 trees is equal to 232. I am going to multiply this thing by -2, which is going to give me -12b minus 4t is equal to 464. I exaggerate my t's because they look like plus signs. Now I was hoping to move that and I had to rewrite it, but no. I'm going to have to rewrite 13b plus 4t is equal to 487, and I subtract. Oh, I like this. Look, because look what happens. B solves to B all by itself. And 487 minus 464 is 23. So if the B is 23 and I plug it in right there, 6 times 23, think about it, 20 times 6 is 120, right? And 3 times 6 is 18, so it's going to be 138 plus 2t is equal to 464. If I subtract, what am I doing? That's 232. Why didn't somebody stop me? There's nobody here to stop me. Okay. So if I subtract 138 from both sides, if it was 132, it'd be 100, and it's 6 less than that. Okay, 6 more, so that must be 94. So t is equal to 47. But look what the last question asked was. Remember to go back and answer the question that was asked. It says, what's the cost of 1 bush and 1 tree? I don't know if they mean this is what the bush is and this is what the tree is, but just in case, I'm going to tell my teacher, well, the bush is 23 and the trees are 47. Together, if you mean together, Miss Wilson, 23 and 47 come to 70. So there you have it. Okay, this one you don't have to pause this because you won't set it up the same way I am. When you're doing physical science, there's this thing called combining velocities, and I need you to get that concept down because it will make your life easier when it comes to physics. And here's what happens. There's, for instance, if you were going whitewater rafting, which by the way is a blast, if you are going whitewater rafting and you are paddling along at 4 miles an hour and you're going downstream with the current, the current is 5 miles an hour, you are actually traveling at 9 because your 4 and that 5 combine to make 9. Conversely, if you were trying to go upstream and you were paddling along, paddling merrily at 4 miles an hour and the current is 5 miles an hour and you're going against the current, you're not gaining ground. You're losing 1 mile every hour. You'll never get to where you're going. And that's called combined velocities. But the deal with that is that you have to keep it in miles per hour or kilometers per hour or whatever they're talking about. So you're going to see me do this problem in miles per hour just because I've been trained to and I like to train you to. So let's say that J is equal to the jet speed. And we're going to say A is equal to the air speed, the speed of the air without any help from the jet stream. But in this case, I need the jet speed, right? So I might as well go ahead and change this to jet speed. And I know because of combined velocities that the jet speed plus the air speed is equal to what? Well, we're going to have to discern that. Use this derived quantity. If you're going 1,800 miles in 3 hours, you must be going 600 miles per hour. Again, I changed this to miles per hour, even though they don't tell me to. This is actually a math counts problem, and I like you to know stuff like this. But if the jet is going against the wind, it's the jet speed minus the air speed. That's going to be 4 hours for 1,800 miles. So we're going to take 1,800 divided by 4. That's easy. Just divide it by 2, which is 900, and then divide it by 2 again, which is 450. Okay. Look how easy this little baby is to solve when you do it like that. 2J is equal to 1,050. So the jet's speed, is 525 miles per hour. So if his speed is 525, the air must be 75 mph, which this cannot be inaccurate. I mean, because that means that the air is already like a hurricane, isn't it? I mean, isn't a hurricane? I don't know. That just seems like really fast air. And I think I would not get in a plane when the air is 75 miles an hour. But there we have it. The answer to this question. What was the jet speed in still air? 525. And the jet stream speed was 75 miles an hour. Oh, it's a jet stream. So that's okay. The jet stream is fast. So that's not a hurricane. It's just our trusty jet stream. I feel better. Okay, this, 2 ways to do it. Most students will do this by guess and check. And I can see you doing that if it's a small number. If it's a big number, that's an act of desperation. But I want to go ahead and solve this for you anyway. The sum of a two-digit number is 7. So let's say A is the first digit and B is the second digit, okay? So if you take the A plus the B, you get 7. But when the digits are reversed, then the number is increased by 27. This is the hard part. Now, on something this easy, I probably would guess and check, but because I want to show you this concept, I won't. So if I reverse and make it BA, it doesn't say, that means I have to do 10 times B, because it's in the 10 times place, right? Plus A is equal to, and it's 27 more than the original number. The original number is actually 10A plus B, and it's increased by 27. Now, if I've lost you, rewind. So now I'm just going to combine this into one equation. 10B, I'm going to subtract B from each side, I get 9B. I'm going to subtract 10A from each side, I get negative 9A, right? Equals 27. Now I'm going to show you another strategy, and you're probably going to be screaming at me now. I hope not. Some of you will follow this. You know, I can simplify that, right? I can divide everything there by 9, which would give me B minus A equals 3. I just divided everything by 9. It's the same equation because I divided everything by the same number. But what I like about that is I can just put it right up here. Negative A plus B equals 3. I'm going to add these. A minus A is nothing. 2B, or not 2B, equals 10. The B is equal to 5. So if the B is 5, the A is 2. So the two numbers they're talking about, the first number is 25. The second number was 52. And sure enough, when you reverse it, they are 27 different. Isn't that fun? Okay. This is, you can tell where I was doing this before. Okay. A farmer buys, now this one I'm not going to give you the answer to. This is a state math counts problem. It's from when the kids went to state competition a few years ago. It says well, you know what? I'm not going to read it to you. I'm just going to ask you, do you know the answer to this? Hope you can solve it. This concludes this abstract problem solving using math counts problems. I hope you're smarter, and I hope you try this a second time. You guys take care.